Hey everyone! Today we're going to review graphing quadratic equations. So last time we kind of just looked at the graphs. Now I'm going to teach you how to graph them by hand. I apologize for this weird watermark in the corner. It's just going to say Smart Notebook and I can't get rid of it, so I apologize. So review from what you looked at last week. We talked about parabolas facing up and down. So this parabola is facing downwards because it's opening down. And then when it opens down, this point at the top, which is the vertex, when it opens down, that's going to be the maximum because it's the highest point. And when you label the maximum, you talk about its y value because the y value is saying how up and down it's going. So the y value here is 2. So the maximum's at 2. The domain people were struggling with, that's all the possible x values. So if you think about a parabola, it's going to keep opening up forever and ever. There's arrows on the end of this, and it's going to keep getting wider and wider, which means it's going to keep touching all these different x values. So for parabolas, your domain is going to be all real numbers. Another way to write all real numbers is to draw the fancy R. So if you're writing it, you could write it like this. You could also just say all real numbers. The range is the possible y values. So you notice it's going to go forever down because it's got this maximum, but it's not going to go up at all. So the highest y value it's hitting is at this 2 line, and it's going to go everywhere down below that. So the y values, the highest they hit is 2, so they're going to be less than or equal to 2. So all the y values you see go smaller than 2. And this number should always relate to your max and min number. So whatever number you have here is also going to go with your range. You're just going to change the sign. So if it's going below it, it's going to be less than. If it had been going up, then you would have been greater than. Let's see one more. So this parabola is opening up. Its vertex is down here, so that's going to be a minimum because it's the lowest point on the parabola. And the y value that that's occurring at is y is -5. So my y is -5. Domain for all parabolas is going to be all real numbers. And then your range, it's going to be the y and the -5 again. And this time the parabola is going up, so it's all the numbers greater than -5. So it's going to be greater than or equal to because it's touching -5. So now that we've reviewed that, we're going to talk about how to actually graph one of these parabolas by hand. So the first thing you need to do is you need to be able to find that vertex, and that's going to allow us to graph the rest of the parabola. So the formula for finding the vertex, to find the x value of the vertex, you're going to do -b divided by 2 times a. So just a reminder in this formula, this is your ax squared plus bx plus c. So in this formula, your a is going to be 1, because that's the invisible number in front of the x squared. Your b is what's attached to the x. So your b is going to include this sign. So if it's a minus sign, it'll be -4. If it had been a plus, it would have been a +4. And your c is 5. So if I wanted to find the vertex for here, I would plug in into my formula -b. So my b is -4. So since it's -b, it'd be -4 over 2 times a, which is 1. So remember, negative makes a positive, so these are going to become positives. So now we have +4 divided by 2 times 1 is 2. So my x value is 2. So I know somewhere at x is 2 is going to be the vertex. So we found half the vertex. To find the other half, you have to plug this value in for x in the equation to find y. So you're going to have y equals, and then for every x you see, you're going to do parentheses and plug in the 2. So I just replaced all the x's with 2. So you get 4 minus 8 plus 5. So that's -4 plus 5. So 1. So y is 1. So you know that the vertex is going to be at the point, the x is 2 and the y is 1. So if I go to the point 2, 1, that's going to be the vertex. Since my a is positive, I know it's going to open up. So immediately I could do a rough sketch. I know it's going to look something like that. So our job next is to find exactly what points this parabola is going to be hitting to make a more precise parabola. So moving on to the next slide. Something else we're going to need today is the axis of symmetry. So the axis of symmetry, remember, is the line that's cutting the parabola in half, so it's symmetrical across the line. So if there's a point here, there also has to, and that's 2 points away from the axis of symmetry. 2 points away on the other side will also be a point. So we're going to be using that as well. So the steps to graphing a parabola, you're first going to find the vertex using our formula. Then we're going to draw the axis of symmetry through the vertex. Then we're going to graph 2 points to the right or to the left of the vertex. And then you're going to reflect those 2 points across the axis of symmetry and then connect everything with a parabola. So feel free to take a screenshot of this slide if you need it. So putting that into play. So looking at this formula, we can see that our A is 1 and our B is 2. So we're going to always start with the vertex. So to find our x, we're going to do negative b, so negative, and then this time b is 2, over 2 times a, which is 1. So negative 2 divided by 2 equals negative 1. So I know the x value for my vertex is negative 1, so that's going to be the first value I put in my chart. So then, to find the y value, we're going to plug in negative 1. Make sure you use the parentheses, especially if you type it into your calculator without the parentheses, it's not going to give you the right answer. So once you type this in, it is going to give you, oh, hold on. Let's try erasing that first. Oh no, okay. It's going to give you negative 1 comma negative 4. So that point, negative 1, negative 4, is going to be our vertex. So the next step on the list is we need to pick 2 points to the right or to the left of negative 1. So if you picture a number line, when I have negative 1, the numbers next to it go 0, 1. So 0 and 1 are going to be the next points I put in the table. So just like before, you're going to plug in 0 and 1 into the equation. So you plugged in 0 for all the x's, plugged in 1 for all the x's, and you're going to get 2 more points on the parabola. So we're going to graph those 2 points. So we'll have 0, negative 3, and 1, 0. So through the vertex, we need to draw the axis of symmetry. So this point was the vertex, so that is the point that you're going to draw your dotted line through. It might even be a good idea to draw that line before you graph more dots so that you don't get confused. So your last step here is you're going to reflect the points across the axis of symmetry. So if I went 1 point to the right, I'm going to go 1 point to the left and put a dot. Here I'm 2 points away, so I'm going to go 2 points away and put a dot. Finally, we can connect our points with a parabola. And since the parabola is going to go on forever, so you can draw arrows going up, and that'll show your parabolas going on forever. It's also sometimes going to ask you questions. So let's look at what the questions are. So this one asks, what is your axis of symmetry? So the axis of symmetry, remember, you have to write it using an equation. So it's always going to be x equals whatever x value it's crossing through, which is also going to be the x value of the vertex. So x equals negative 1. And I've lost contact. There we go. Another reminder is that the roots of a quadratic equation are the x-intercepts. So whenever it talks about roots, you're thinking about the 2 points where it's crossing the x-axis. And the other name you might see for these are zeros. So x-intercepts, zeros, and roots all mean the same thing. So examples of types of graphs, if it has 1, 0 or 1 x-intercept, it's only going to be touching the x-intercept, the x-axis at one spot. So it could look like this. It could be touching here. So it only hits in one place on the x-axis. If it's got 2 zeros, that's going to be parabolas that cross twice. So it's going to be hitting in 2 spots. And then if it has no zeros, that was the no solution example we looked at in this folder. And that's never going to hit. So it could look like this, it could look like this. However, if you try to draw a parabola like this, those arrows are going to keep going up, so that's actually going to have 2 zeros. So you want to make sure it's facing so the arrows will never touch the x-axis. So the last problem we're going to look at is we're just going to do one more example like this. So if you don't need to watch it, you can stop. But if you want to see one more example, I'm going to show it. So once again, we're going to start with the vertex. So we're going to do negative b. So your a is the negative 2. Your b is negative 8 this time. So for the vertex, we're going to do negative b. So it'll be negative negative 8 over 2 times a, which is negative 2. Remember, negative negative 8 is positive 8. And then 2 times negative 2 is negative 4. So our x-axis, our x-intercept, our x value of the vertex is negative 2. Then we're going to plug that in to find the y value. So every x you see, we're going to plug in negative 2. So with that, you can see that we're going to have -2, -7 as our vertex. So if I go to the graph and I go to -2, -7, you can put a point. Honestly, at that point, I would immediately draw the axis of symmetry. I know I skipped that on the last one, but I would draw that dotted line so you know that that's where your vertex has to be. Then we're going to pick 2 points to the right or to the left of -2. So you could do -3, -4, but I personally prefer -1, 0, because those are to the right of -2. So you would plug those in, and you would get -1, -1, 5, and 0, -1. After you have those points, you're going to reflect them across the axis of symmetry. So we're 1 to the right, so we're going to go 1 to the left. This one's 2 to the right, so we're going to go 2 to the left. And then we can connect our points. It looks like I counted wrong. What did I do wrong? All right, looks like I wrote it wrong. So it was actually -2, +7. So you'd go to -2, +7, then -1, 5, and 0, -1. There we go. So the reason I knew I did it wrong is because there was a negative in the front, so I knew it needed to open down, and the parabola I was drawing was opening up. So that's how I caught my mistake. So 1 to the right, so 1 to the left, 2 to the right, 2 to the left. Then you can connect your points, and it's opening down, so we know it's closer to probably being correct. Questions that it's going to ask, so axis of symmetry, once again, that's the x value of the vertex, so it's going to be x equals -2. Your zeros are where it's crossing the x-axis, so I actually picked a bad example for this, so you cannot see the zeros. So we're going to ignore this, but it would be where it's crossing the x-axis, mine are just decimals. The maximum point is the highest point, so the highest point it's hitting is at y equals 7, so that's going to be the y value of the vertex. The domain for all parabolas is all real numbers. And then the range, the highest point it's hitting is the 7. So we know it's going to be a y and a 7. And then this parabola is going to all values smaller than 7. So it's going to be less than or equal to 7. All right, why don't you guys try the assignment and try graphing your own parabolas.